In this video, I explain merits and demerits of arithmetic mean. But if you are new on my channel Statisticians Club, please subscribe the channel. Now let's start. First we discuss merits. Number 1. Readily defined. It is readily defined by a mathematical formula. As you know, mathematical formula for ungrouped data is x bar is equal to sum of x over n. Sum of all observations divided by n, and for group data sum of f of x over sum of f. And arithmetic mean also has short formula and coding formula. In other words, we can say that we can define arithmetic mean on the basis of mathematical formula, so it is readily defined. Number 2, easy to calculate. It is very easy to calculate. Its calculation is very simple. Easy to understand. It is easy to understand. There is no difficulty or hurdle to understand the arithmetic mean. It is very simple and easy to understand. Number 4, based upon all values. It is based upon all values. If you have a data set and someone calls you to calculate its arithmetic mean, you use all observations to calculate arithmetic mean instead of mod and median, where all observations cannot be used. So arithmetic mean is based upon all values. Repeated. It is stable statistics in repeated sampling experiment. If we repeat the sampling experiment, arithmetic mean is a stable statistic. Number 6. Sum of observations. The sum of observations can be found if mean and number of observations are known. If you know about the mean and the number of observation, you can find the total number of observations. For example, x bar is equal to sum of x over n, and you have x bar mean is equal to 4 and n number of observations are 5. By cross multiplication, 5 multiply with 4, 20. It means sum of observation will be 20 in this scenario. So if you have mean and number of observations, you can calculate the sum of observations. Demerits. Number 1, sensitive. It is very sensitive to any marked departure from bell-shaped distributions. Bell-shaped distributions, other name of bell-shaped distribution is from normal distribution, and hence is not suitable for skewed distributions. And arithmetic mean is not suitable for skewed distributions. Here we understand what is skewness. There are two types: positively skewed and negatively skewed. If your data set have more than positive trend, values are more values are positive, then it will be lie on positive side, so it is positively skewed. If your observations are mostly lie on negatively sides, and this is negatively distribution. Bell shaped or normal distribution is equally division of positive and negative values. So arithmetic mean is suitable for bell shaped distributions, but it is not suitable for skewed distribution. Number 2, misleading. It gives fallacious and misleading conclusions when there is too much variation in the data. If your data set have large variation or too much variation in the data, so arithmetic mean is misleading in such scenario. Extreme values. It is greatly affected by extreme values. If your data has set like this 95, 98, and 3 values are 40, 26 and 32. So there are two extreme values, 98 and 97, and these will have a large impact on the remaining data set. So arithmetic mean is greatly affected by extreme values. Extreme values will be positive or negative. In other words, we can say that extreme values, the values that are lying outside the range of data, are too far from the mostly the trend of the data. It cannot be not to calculate. It cannot be calculated for open-end classes without assuming open-end. As you know, open-end classes is means less than 5 to 10. So this is open-end classes when one end is missing. To calculate arithmetic mean, we first calculate open end and then we calculate arithmetic mean. If you want to see videos about solved numerical of measure of location, what is scale of measurements, then click the link in front of your screen. Thanks for watching.